Hello, dear students. Welcome to the new episode that I'm going to give a series of lectures on these complex analysis. I'm going to discuss some of the basic concepts that we use in some different these mathematical techniques that we discuss in our course that we will discuss in our course. So first of all, if we talk about these complex numbers, so you might have heard about these complex numbers. Something we were writing some number as some real plus that imaginary number. That's our complex number, right? So if you see here, I wrote here. So how complex numbers are used in day-to-day life? So how we are using these complex numbers in real life, right? So it has many applications in different fields of this science and technology. So first, if you talk about these complex numbers, you are writing that a complex number can be written as some a plus iota b, where that a and b are our these belongs to our real numbers, and this iota is our imaginary number, right? So this is very clear. Now, so let's talk about the different applications in the different fields of science and technology. So first, if you talk about that, so it has first application. We can use these complex numbers in electronics, right? We can use it in some electromagnetics. So like in the physics, we are using it in electromagnets. I will explain you how we can use it in electromagnetic waves. Or you can have the solution of the quadratic equation, right? So if you talk about the quadratic equation, so depends upon the discriminant. So either discriminant can be greater than 0, equal to 0, or less than 0, right? So if discriminant is equal to 0 or greater than 0, so then it's clear, because roots can be real and unequal, or roots can be real and equal, depends upon discriminant इसका क्या होगा. If discriminant will be 0, roots will be equal and real. But now the third case is that if the discriminant will be less than 0, so in that case our roots will be imaginary. So it basically helps us to find the solution for the quadratic equation where our this solution is not clear, right? So in the form of that imaginary numbers. So this was another application, and the next application is in computer science. So we can use it in computer science also. Even if you talk about in engineering field, like in civil and mechanical, this mechanical and this civil engineering, we are using these complex numbers, and we can use it in our that this basic physics course, that is basically quantum mechanics. We are using these complex numbers in quantum mechanics also, right? So let us discuss one by one. So first is, if you talk about these electronics. So if you talk about the electronics, so you can this plot this voltage and the current on this the complex plane also, right? So that means you can write that if we have this voltage, so you are plotting voltage from this side and the current from this side, right? And if we consider some point, so suppose that's Z, so it's a function of that Vn, right? And the projection of this complex number, because our Z will be in that case, so that will be equal to V plus iota. So this voltage and current, right? So we can also plot this voltage and the current, and this Z is our complex number, so this can be written as the combination of that real part, that's the voltage along the x-axis, and the current which is along the imaginary axis, because this is our real axis, so this is our real axis, and this one is our imaginary axis. So ये हमारे real axis है, it takes the real values, and this takes the imaginary values, right? So that's why I put here that's V plus iota, right? So or rest of that, if you talk about that, or if you write the resistor and the inductor also, so you can take the combination and you can draw it on this on the complex plane, right? Now the next, okay, so next application is that if you use it in electromagnetism. So why we use these complex numbers in electromagnetism? So you can find that if you want to plot that electric and magnetic field, right? So you can plot that electric and magnetic field on this xy plane, because this is our real axis and this is our imaginary axis. So this RE stands for our real axis and OM stands for imaginary axis. So that means our horizontal are this real axis and this vertical are our imaginary axis, right? Now, so you can also write the electric field will be from this point. So if you consider any point here, so that will be equal to the function of, it has two coordinates here, right? And so B will be along this direction and this will be the electric. Right? So So that means we can also draw this electric and magnetic field on this complex plane in electromagnetism, right? And in addition to that, we can also use to calculate the roots of quadratic equation also. So this is very clear because if we consider some quadratic equation like so ax square plus bx plus c equal to 0, right? So and you can calculate the discriminant, right? So discriminant is that is so discriminant you are writing that minus b. One, right? So this is the discriminant. So that is you can calculate from here. So ABC are all those real numbers, right? Now, important condition that A should be non-zero. So B can be 0 or C can be 0, but A should be non-zero in that case, right? Then it's a quadratic equation because otherwise this square term will diminish here, so it will so it doesn't become so a quadratic equation nahi banegi, right? So necessary condition that A should be non-zero in that case, right? Now in addition to that, so that means if our discriminant is greater than 0 or equal to 0, right? So root is यहाँ पे real होगा. यहाँ पे रूट्स रियल हो सकते हैं बिकॉज डिस्क्रिमिनेंट इज पॉजिटिव और डिस्क्रिमिनेंट इक्वल टू 0. सो अगर हम डिस्क्रिमिनेंट ग्रेटर देन 0 लेंगे इन दैट केस आवर दिस रूट्स विल बी रियल बट अनइक्वल, राइट? और इफ डिस्क्रिमिनेंट इक्वल टू 0 रूट्स आर इक्वल एंड real, right? But there is the third condition that if you consider that discriminant greater than 0. So in that case, roots cannot be real in that case, right? So roots will be imaginary, right? Because in that case, our solution is not clear. So you are writing it in terms of some imaginary value, right? So this is why you can find this application, or for example, or you can take that x square plus 1 equal to 0, right? Or x square equal to minus 1, or x equal to root. Okay. So this is, sorry. So this will be minus 1. So that's equal to 5. Right? So it is root will be imaginary. So this is our quadratic equation. So you can calculate its root comes out to be imaginary, right? Now, in addition to that, we can also find these complex numbers in computer science also. So why basically we find its application? So this data that you see in that in our system, so that cannot be seen visually, right? So because जो हमारा data होता है, it is in the form of CSV format, right? तो जो यहाँ पे डेटा होता है that is in the CSV format. That is comma separated. So CSV format में होता है. तो जो कंप्यूटर साइंस में डेटा होता है, it cannot be visually seen because it is in the CSV format. Because अगर हम कोई भी फाइल देखेंगे, it has its own extension. Like we have that .pdf, .txt also. So this data is in CSV format. That is basically comma separated variables, right? Now, so that CSV format can be visualized. That can be seen. Representation, so that can be seen in the form of that complex plane. So we can see that data, that CSV format in computer application in the form of this complex representation. Or if you talk about the two-dimensional representation, because we're usually plotting that if we consider anything, so we're plotting in the two dimension, right? Or you can visualize that format, that CSV format in the 2D form also, right? So this is another application of that these complex numbers that that can be used also in this computer science also, right? Now, one more that application is that we can use it in the mechanical and civil engineering also, right? So you might have heard about that when anybody, when an engineer, if you talk about a civil engineer, he needs to construct a building. He has to make the design. So that design, he basically makes the two-dimensional vision. So that you can say that two-dimensional design concept, right? So that mainly depends on the these complex numbers, right? So he makes that two-dimensional on this complex plane, right? So that means like if you talk about the design, अगर इसको कहाँ डिजाइन करनी होगी, और if you talk about the designing a building, right? So he needs to make that plot in that complex plane, right? So this is why these engineers also more often use these complex numbers in day-to-day life in their work, I can say, right? Now the another this application that you might be familiar, because if you are from physics background, so you are you might be familiar with this Schrodinger equation, right? So we have this if we write that E psi equal to operators. So why do we use the complex numbers? Because if you remember that each term is clear to you. So हर कोई term आपको clear है because E corresponds to our energy, and so this is our imaginary number, that iota, right? H is Planck's constant, so it's clear to you, right? And this H operator is our Hamiltonian operator, right? So it is basically that kinetic plus potential term, right? Okay, now my question is that if you talk about this equation, so this is the fundamental equation in quantum mechanics, right? Like we have this equation like Newton's law F equal to ma. So this is the fundamental equation that we use in this classical mechanics, you can say. So similar, we have this fundamental equation in quantum mechanics also, right? And what I mean to say here that if you talk about that psi, so psi, अगर हम psi जो हमारी wave function होती है, psi is the wave function. अगर हम psi real value लेंगे, if we take the psi real value and we act this H operator on this thing, so it comes out to be a real number, right? But so on the right hand side, on the left hand side, this term is imaginary because it is multiplied by that iota, right? So यहाँ पे iota मैंने multiply किया है, and it is completely imaginary here, right? Now on the right hand side, it's real. So that means it is mandatory, it is important that our psi should be complex, right? So that means it is important that our psi should be complex. Right, so psi can be some, it can be some a plus iota, right? Because अगर ये complex होगा, then this term equal to this term, right? This is an equation. So our right hand side should be equal to left hand side, right? So this is only possible when our psi will be complex, right? Then we can take that psi star, that psi square, that basically gives us the probability. So that's not our the question at this point. So our main reason, main aim is to why we use this, why our wave function is complex, because that h psi should be equal to e psi, right? And we have this imaginary number. In order to make that psi imaginary, psi should be complex. It can be some a plus iota b form, right? So these are some of the applications of these complex numbers that we use in day-to-day life, right? So let us come back to our basics, these complex numbers, because as I mentioned earlier that we will discuss about some of the basic these concepts about the complex numbers, its different form, or the different identities or the properties of these complex numbers. In addition to that, we will also, I'm going to solve some of the problems that will be most probably asked or that have already appeared in some competitive exams like GATE, NET, SET exams, right? So first, so before starting the problem on some topics, so I will give you some of the basic concepts that we use in that topic, right? Now, if you talk about the complex numbers, so we are saying that if we have, if we consider that so we are saying that a number is said to be complex number if it can be written as x plus iota. Okay, and while this x and y, so that means x and y हमारा real number है, right? But this iota makes it imaginary, right? So this is our complex number. So that means that is our complex number. So that means that basically lies in the complex plane, right? So we can see that. So if we have this complex plane, this is our real axis, real, and this is imaginary. Right? And if we draw this, if we draw this point, so this can be somewhere here in the first quadrant. So this is our z, and this is the x end, right? And the projection of this, so this is a complex number that lies in the first quadrant of this complex plane. And if we draw the projection from this point z on the x-axis, on the real axis, on horizontal axis, and on the vertical axis. So this basically gives us a component. So this is our x and this is our y, right? And so this is the distance from here, and it makes some angle theta with this, right? If you want to calculate now, so that means so this is our that complex number, right? If you want to calculate what will the real value of this complex number, so that means if you take the real value of this z, So that will be x, and imaginary value of this z. Okay. So that means this is simple, the basic concept about this complex number. Now, instead of that, if we have two complex numbers, if we have two complex numbers z1 and z2, right? So this z1 will be equal to z2 if their corresponding real and imaginary numbers will be equal, right? So that means if we consider now, if we have this z1 equal to x1 plus iota y1, and z2 will be equal to. So then z1 will be equal to z2 if x1 equal to x, comma y1 equal to. अगर ये equal होंगे, then we can say that z1 will be equal to z2, right? And if you calculate now the modulus of z, so what basically modulus of z is? So modulus basically gives you the magnitude of that. So that means it will give you the distance from this origin to this point, right? Okay. So that means this basically gives us that modulus of z, right? So modulus of z, that means you need to take the square root of the square of these real numbers, the real part and the complex part, right? So that means if you write now, what will be the modulus of z? That will be equal to. Okay. So just check. अगर हम यहाँ पे निकालेंगे, what will be that modulus of z? So this is our that y component and this x component. So this is y component, this is y component, and this is x component. So using that Pythagoras theorem, that modulus of z square will be equal to x square plus y square, or mod of z basically gives us that square root of x square plus y square. This is what I wrote here, that mod of z will be square root of that. Okay. So that means अगर हमारे पास complex number होगा, तो अगर हमें इसका magnitude निकालना हो modulus of that, so you need to take the square of those real and imaginary parts. So leave that iota as it is, right? So this is how you can calculate that modulus of z, right? Also, if you calculate now the tan theta from there, so this is clear from here, because tan of theta is, because tan of theta will be, that will be y divided by x, right? Or you can write this as theta will be equal to. So this theta is, it is called the argument of z, right? So this theta is this is called the, okay, or you can write this as, this is argument of z. Okay, and you need to take this angle. So if you remember, so just check. So I'm taking this. So this angle should be, you have to take it counterclockwise, right? So starting from this, the angle that is made by this complex number with the positive real axis of that this plane, right? तो ये जो एंगल बनाएगा किसके साथ, जो रियल एक्सिस होगी इस कॉम्प्लेक्स प्लेन की उसके साथ. But take this direction, take this direction counterclockwise, right? Okay. So this is how we can define the complex number, how we can define the argument of a complex number. And in addition to that, so there are some properties. So we can discuss some properties. We can take the addition of numbers. We can take subtraction of these complex numbers, right? So we can have this. So we can calculate what will be that z1 plus z2, right? So before that, let me take one more thing. That is, so if you take now, because our z will be equal to, so ये हमारा complex number है. Now if you take the complex conjugate of that, right? So that is, if you take that z star, so that's equal to x minus iota. So why this complex conjugate of this complex number lies? So that means you can have this. So this is our origin. This is our real axis. Imaginary. So this is our z. So if you take the complex conjugate, so that is x minus iota y, right? So that means it will be somewhere here. So this will be that. Uh, this will be that so Z star. So Z star it will lie in the fourth quadrant of this complex plane, right? Because it's very clear. So that means it Z lies in the first. So it's not necessary. So you can also take. So there may be some complex numbers which may lie in some different coordinate systems. So depends upon the value of that number. Like if we have that minus x minus iota y, right? That's also a complex number. And so we can right now, instead of that, we can also prove some of the identities, right? If we have, we can take the addition of the two complex numbers, right? If you take that z1 plus z2, right? You can take z1 minus z2. You can take z1 and z2. You can take z1 divided by. Right? So there are so many properties. So you are, I think, you are familiar with these things. So I will not discuss these things because if I need it sometime, so I will use them. And like if you talk about this, so this will be simply that it will be that 2x, that is twice the real value of x, real value of this z, right? And you will get here twice iota y, right? So that will be equal to twice imaginary value of that, right? And similarly, we can take when you take the product, right? So you can prove these relations. In addition to that, we have these this triangular inequality. Suppose if you take the addition of two complex numbers, take their mod. So that if you want to split, so there is inequality. So either it is greater or equal to, or it is less or equal. Depends upon that if you take the addition or if you take the subtraction. So that's basically called a triangular inequality, right? So we'll discuss that in our coming lecture. So this was the basic lecture, and hopefully in our coming lectures I will also discuss about some other problems that has been asked maybe in some competitive exams. Hopefully these lectures will be helpful for you. Thank you very much.